Everything you see or smell is made of atoms. The water that you drink every day, like in this cup, is made up of H2O molecules, H2O, and each H2O molecule is created from 2 hydrogen atoms and 1 oxygen atom. Just to give you an idea about how small these things are, H2O molecule is something like 0.27 nanometer in size. That is 0.00000000027 meter. And in the second picture there is a person breathing in some air, so let's say you need oxygen to survive, so that's O2, which is made up of oxygen atoms, 2 oxygen atoms to be precise, and then you breathe out CO2 mostly, which is carbon and 2 oxygen atoms. Different types of atoms can combine to create molecules like water and oxygen and carbon dioxide, and different types of atoms forming different molecules creates the world around us. And in this lesson we will answer what are atoms, how do elements differ, and what is periodic table. So let's start with atom. Each atom is made out of nucleus and an electron shell. In the nucleus there are protons and neutrons. And in the electron shells there are electrons. Okay, it's probably not as visible from this picture, but the nucleus is actually very small compared to the electron shells, and the electron shells takes most of the volume of the atom. However, the nucleus is the heaviest part of the atom and it gives it the most weight. So to summarize this, we can make a little table. So protons, neutron, and electron. And the relative mass of these will be 1 for proton, 1 for neutron, and for electron it's very small but not 0. Okay, so we know that nucleus will make up the most weight of the atom, but what about the charges? So proton has relative charge of +1, neutron has no charge, and electron has negative charge of -1. So that is the relative charge. And from this you can see that for a neutral atom, the number of electrons and protons must equal. Okay, so the number of protons in the nucleus will actually define what type of atom this is, what element this is. So here is a periodic table of elements, and as you can see, on the top there is the atomic number here. So for hydrogen it's 1, so that means that hydrogen has 1 proton in its nucleus. And helium has 2, so it has 2 protons in its nucleus. And you can go this way until the end. So basically we're adding the elements by increasing the atomic number, so the number of protons in the nucleus by 1, okay? But you can see that the atomic weight is never a whole number. So why is that? And the answer is that the elements can have different number of neutrons in its nucleus in the nature. So for example, let's say carbon. Carbon is here. It has atomic number 6, which means that carbon has 6 protons in its nucleus. we're going to put the 6 here. But actually in the nature the most abundant carbon is carbon 12, which means that it has 12 minus 6, which is 6 neutrons. However, there is also less than 1% of carbon in nature is carbon 13, and that makes 7 neutrons. Now, as we said in the table above, let me just take you back. The relative charge and the relative mass in this table, the relative mass of neutron is 1 and proton is 1, while the electron is very small. So if we change the number of neutrons, we will obviously change the mass of that element or that atom. And that's why we have names for these things, and it's isotopes. So isotopes is an atom, or isotopes are atoms with the same number of protons but different number of neutrons. And the atomic weight that you see in the periodic table is basically the average of all isotopes, of the weight of all isotopes in the nature. Okay, so let's summarize what we've learned so far. Molecules are made of atoms. And atoms are made of neutrons, protons, and electrons. Protons and neutrons are in the nucleus, while electrons are in electron shells. The nucleus is the heaviest part of the atom, and the electron shells and the electrons do not contribute much to the mass of the atom. So, different proton number means different elements. And we are adding the elements to the periodic table by increasing proton number. We have also learned that the atomic weight in the periodic table is basically the average of all isotopes. Of that element.